ready.
Hello, welcome to Enlightning. I'm so excited for today's episode. We're going to talk about Observability 2.0, which I don't even know what that is yet, which is very exciting. I'm here with Adriana Villela. Tell us about yourself, please, Adriana.
Hey, Whitney, thanks so much for having me on. I am super excited to be here.
Me too.
Background. Well, I guess the short of it is I've been in tech for 20 plus years, started coding when I was 10 because my dad's like, hey, want to see something cool? And showed me how to code in BASIC. Did not like it at first. So I never touched a computer again. And then in university, I rediscovered a love for programming. Go figure. So I'd say the first 15, 16 years of my career were spent as a Java developer. Then I got to a point where I was like, don't want to do this anymore. I'm going to be, I'm out of tech. I was a professional photographer for a year. The best worst year of my life. Because I picked up really good skills, but realized I was quite miserable and didn't actually want to be a professional photographer. For future aspects of my career. And then shortly thereafter, I got into the DevOps space as a result of horrible go live where everything went wrong. So it was like, oh, DevOps is the void that, was missing in my life or filled the void in my life, I should say.
Okay.
And so I ran a DevOps program at a major Canadian bank for, I want to say 3 years. Then after that, I took a step back and did some IC work, just building up some Kubernetes skills, then went back into management, managing an observability team. And that's when that's more or less when I got into observability.
Yeah.
To manage this team. I was managing 2 teams and one of them was an observability team. And I'm like, well, if I am going to manage this team, I better actually know what I'm talking about. So I educated myself and as part of it, shared my observability journey with the world through my blogs. And I'd been blogging already on various aspects of Kubernetes at that point. So then my blog was very focused at that point on observability and also on HashiCorp Nomad, because that was the other team I was managing, was like a HashiCorp. So I was like learning both things at the same time. And then because of my observability writings, I got recruited by Lightstep, which is now owned by ServiceNow, as a developer advocate. And I've been a developer advocate for 2 years, but I think I feel like I've been doing advocacy unofficially for like a huge chunk of my life. And a lot of the skills that I have from that are thanks to my photography days. So
that's amazing. So you've made an observability course you told me about, which I think is super cool. So that's on O'Reilly. And is your blog the Medium?
My blog's the Medium one. Yeah. So I've got
if you want to check that out
on observability, also on Kubernetes. I did a lot of exploration with Argo CD as well.
Cool.
So yeah.
And then you also have a podcast.
I do. It's called Geeking Out. And I have a variety of folks from tech on there, but one of the things that I'm most proud of is that I really highlight a lot of amazing women in tech. So we've had I've had Charity Majors on, I've had Kelsey Hightower on. I'm going to have Liz Fong Jones on for the upcoming season, and just some really amazing folks like Abby Bangser as well.
I love her.
She's amazing, just great to talk to.
Would you say your podcast is more technical or more like life stories?
I'd say we get into a little bit of both. It kind of depends on how it rolls. Like our last episode was kind of funny. Like I just wrapped up this season, going on summer break, and I had a guest on, Diana Pham, and she's a developer advocate at Vonage, and she was talking about how like she does pageants, and she would pay her way through school, and we recorded it live, or not live. We recorded it on site at Cube Huddle, and it was it was a little bit unhinged, but lots of fun because our conversation just ended up going everywhere. And we ended up having like Tim Banks was like talking in the background, and then my daughter and Hazel Weekly showed up like right behind us as we're talking. Like they started again, which is not normal for the podcast, but I thought like that was such a fun way to wrap up the season. So, but we get into some very technical topics too.
Yeah, a little bit unhinged is interesting and fun.
Yes.
I'm going to take our banners off to make more room. So if you want to know our handles, take note now, or just rewind a bit. And then we have a comment from Hiriam. Thank you for being here. Observability is awesome.
Yay!
Yay!
I agree.
So on Enlightning, I'm just a few episodes into a whole series I'm doing. I hope to cover all of the CNCF observability tools, which there are a lot of them. But it didn't take me long to realize, like, oh, this observability thing is way bigger. Like the amount, it's funny, I go into these, I did, so earlier this year, some of last year, I did a whole big series on all the Kubernetes security projects. But I go into this this whole new domain knowing almost nothing. And so this is kind of, I realized I could really use an episode that just helps me understand the observability landscape in like a high level, like a big picture view before I zoom in and learn about each one of the tools. So that's why I have Adriana here to tell me Observability 2.0. But before we do Observability 2.0, I need to understand Observability 1.0. Like, what problem is? Yeah, what problem is Observability 2.0 solving? And a quick hello to Napalm Codes. Hello, so glad you're here, friends. Cool.
Okay,
so we're going to start with what is Observability 1.0.
Yeah, let's start with like the base definition of observability, which is the ability to understand a problem from the outside without having to look deep in the innards of your code, right? Because your code is emitting enough information so that you can follow the breadcrumbs to answer the question, why is this happening? So that's I think the classical definition, I will say classical definition, coined by charity majors who got that, who was inspired by the definition from control theory, which I love. And
so Observability 1.0 is basically being able to ask arbitrary questions of your system is the goal of observability.
So yeah, the goal of observability, and there's I would say there's been like in the last few months, there's been like, and I'll say like without putting the labels observability 1.0, 2.0, like the ultimate goal of observability is basically, and this is a refinement on the original like charity majors definition, which is now I call it the Hazel Weekly definition of observability, which is I think is a really cool definition, which is the ability to ask meaningful questions of your system and get useful answers.
Oh, that's nice.
Yeah.
Okay, so it sounds like there was a 1.0 version definition.
So there is. I guess the point of confusion is like, what's the difference between 1.0 and 2.0? Because like that, so the definition I gave you, that is the definition of observability. Now, when observability started out, a lot of organizations were like, they have APM products, right? And they're like, okay, and now this observability thing is becoming popular, right? And so a lot of companies pivoted basically, oh, I'm APM, but now we do observability too. So it's in a lot of the sense that like when DevOps became a thing or SRE became a thing and all these ops teams were co-opted into DevOps teams. Yeah. So observability 1.0 is kind of this recognition that like companies are just starting to come to grips with like observability and coming to grips with what it means. So it's almost like Observability 1.0 is like kind of we're emerging from like APM, like application performance monitoring.
So Observability 1.0 focused on application performance monitoring.
Yeah, I would say so. Yeah, I think that's what it, I don't think that's what it was intended to be, but I think that's what it ended up being, right? So, and so to reframe that a little bit, like it's because I think like it's, or rather than say focused on, I would say it was like it's stemmed from APM to a certain degree. Like that's where, because that's where a lot of I'd say a lot of vendors just didn't know what to do with it. You know, they're like, oh, well, aren't they the same thing? So Observability 1.0 is the recognition that you have like these multiple sources of truth. You've got your traces, your metrics, your logs, right? There was like nothing that was knitting them together. So it's like, you know, we hear about the 3 pillars. Those are the so-called 3 pillars.
So folks were collecting the 3 pillars, log, metrics, traces, but they didn't know what to do with them, or they didn't know how they relate to each other, or have a comprehensive view of how they relate to each other, at least.
Yeah, exactly. And I would say instead of focused, I would rewrite it as like evolved from, I would say.
Okay.
That's probably like a better way of saying that it evolved from APM rather than focused on it.
Okay. I like this.
Sorry,
I love this. No, I was just saying, like, I like how this is a collaboration.
Awesome,
and, yeah, I enjoy it. Evolved from. So collecting logs, make it metrics, traces.
But they weren't like necessarily, there was no correlation between them.
But not yet knowing how to stitch them together.
Yeah,
knowing how they relate to one another.
Exactly, yeah.
What about the spaces in between the stars? Okay.
And then just a slight refinement on the definition of observability. Instead of saying arbitrary questions, I would say useful questions and meaningful, or meaningful questions and useful answers. Yeah, that's.
This is a great starting point. Cool.
Awesome.
So now I understand the goal and I understand the problem. Logs, metrics, and traces, we have them. Now what?
Yeah, exactly.
Yeah.
And the other, like the other thing to note about Observability 1.0 is there was a lot of focus on, you know, how to operate your code. And also there was a focus on those known unknowns. It's like we've encountered those problems before. And by the way, I got to give like full props. Like Charity Majors is the one who coined Observability 2.0 and you know put forth these definitions of like 1.0 versus 2.0. And I think it's really important to recognize that, because like observability is an evolving space, right? So we had to start somewhere.
All right, Charity Majors name on the. Although her name is
so the definition for Charity Majors gave the original definition of observability, which was the control theory definition. This definition is from Hazel Weekly.
Oh, okay.
And Charity Majors coined observability 1.0 versus 2.0.
Okay.
I know it's a lot to unpack. I'm like, we've got a lot to like keep up with.
It's great. So this Observability 1.0 had a lot of focus on it, and you said two things, but now I don't remember either one.
So it was a focus on how you're operating your code.
Uh-huh. Okay.
And then also focus on known unknowns.
Okay.
And it was basically this idea of like, our software systems were a lot less complex, right? So, in the olden days of the monoliths, software was a lot more predictable. People could still do unpredictable things, but there were very predictable. It mostly behaved in very predictable ways because our architectures were a lot simpler, right?
Yeah. Well, it makes me think of like, okay, when you play Super Mario Brothers, it's all the levels, what they look like, the beginning and the end, and that's a lot easier to measure. Like you'd have known unknowns. But then if you play a game like Minecraft, now that gaming has evolved, where you have like procedural generation, you don't even know what the edge of the world looks like unless you walk over there. Observability, observing Super Mario Brothers is very different than observing Minecraft.
Exactly. Yeah. All right. So are we ready for Observability 2.0?
Yes.
So Observability 2.0 is basically where we want observability to be at, and which I think is where it honors that, the original classical definition that we got from Charity Majors and then evolved into Hazel Weekly's definition, which are the attributes of our observability 2.0 is that we have like a single source of truth, because it's this idea that like your signals, i.e. your traces, your metrics, your logs, they're all correlated. So it's almost like they're all seen as one, right?
Oh.
And so they're working in conjunction to provide you information about your system. And one of the things that I would say is important about that as well is like one of the things that I actually say in my O'Reilly video course is that like traces, metrics, and logs, they're all like a special type of event. An event is basically something that happened at a particular point in time, and it's structured. It's structured and it has a timestamp. And traces, metrics, and logs are all special types of events. So they all stem from the event. They all serve like a specific purpose to tell us different things about our system, and they're all correlated so that we have sufficient information so that we can ask those questions and we can get those answers that we seek.
So is it right to say logs, metrics, traces work together to give a holistic view of your system?
Yeah, okay. That sounds good. Yeah.
Now, how do I spell holistic? I think that's right. I'll just say a system. And then you, so they're correlated, they're events.
Yeah, they're like the basis, like the root. They're all rooted in events, basically. And some people may there's like different schools of thought around this. But I like to think of them as like they're all different types of events. They're all specialized types of events that each serve a very specific purpose to help us understand the whole.
Cool. I'm going to say hello to a couple of people. We have Nikos here. Hello from Greece. So cool. And Code with Sean's here too. Hi, Code with Sean. Thanks for coming. Cool. So great. Now we know these work together and we can get a holistic picture. I guess the next question is, how do we do that?
So
like what? Yeah. Is it different tooling? Or maybe you have more to say about this too.
Yeah. So then Observability 2.0, where this idea of like, we've correlated all these things, all these signals, awesome. And now really it's about how it's not just about how you're operating code, but you're also bringing development into the narrative. Actually, you're bringing the whole friggin' SDLC into the narrative, right? Because before, like in monitoring land, it would seem to be more of a concern of your operators, of your SREs, the folks who are, monitoring your systems. But now it's everybody's problem, not just your operators or SREs or platform engineers problem.
So it's not just about operating anymore.
It's baked into your SDLC basically.
What's SDLC?
Oh yes, your system development lifecycle. So from the inception of like your code to all the way to the end. So rather than, you hear this term of like shift left, this is literally left because it's a concern earlier on rather than under Observability 1.0 as it evolved from APM, where it was like shifted way right. We're like, no, we actually need to care about this way earlier.
I gotta say, Kat, hello to Kat who's here. I'm so glad you're here, Kat.
Hey, Kat.
So Code with Sean is helping with the acronym too. Code with Sean said the S for SDLC could be either system or software development lifecycle.
Totally.
That's helpful. I will go back and make flashcards of the board. So when I hear an acronym the first time in the show, I'll memorize it. I'll make a flashcard and memorize it. Yeah. Okay. Sorry, that was tedious. All right. SDLC. Okay. So Observability 2.0 is about the spaces in between the stars, about how they're related to one another, how getting a holistic view of the system by having our signals, our logs, metrics, traces working together.
Yeah. So it's really about realizing the promise of observability in the first place. We can look at Observability 1.0 as like, that was our first attempt and, nice job. We started. 2.0 is like realizing the dream, like getting closer to hitting nirvana.
So logs, metrics, and traces together can be called signals or the three pillars.
Yeah, I personally don't love the three pillars and the reason why I don't like three pillars because it implies silos, and because they're like interwoven, then it's anti-observability 2.0.
It's true. We all make a part of a complex whole, just in life in general. I think it's human nature to be like, oh, I'm going to take the healthy part of turmeric and then that's going to be the thing. And it's like, no, you need all of it for your body to know what to do with it. So I like that we're looking at the whole. That resonates with me on a human level. But I guess so I understand the old way, logs, metrics, traces. I have maybe a single tool for each thing. Yeah. And then I get that and maybe a dashboard that will help me view them at least at the same time and maybe correlate them somewhat. Yeah. So how do I actually do the action of evolving to the 2.0 type where I can ask any meaningful question I want and expect to receive a useful answer?
So I think, so to clarify a little bit, I would say under Observability 1.0, we were still seeing a lot of like, oh, I use this tool for this and this tool for this and this tool for this. And we try to correlate it. Or sometimes you would have like, maybe as you said, you would have like a single tool for all three, but it was up to the tool to correlate. And in Observability 2.0, I think we're seeing a lot more of a movement towards like, we recognize that we need all these three signals working in conjunction with each other. And therefore they have to be, I think to really be effective, you have to be able to have them under a single umbrella, single tool. And that the correlation shouldn't be the burden of correlation should not be put on a tool like a vendor tool, but rather on a framework for emitting those signals. And that's where we have OpenTelemetry.
So OpenTelemetry is the big difference.
Our lovely friend.
Okay, so back in Observability 1.0. Okay, so I'm going to refresh. We did an episode on OpenTelemetry, and let me state two things and make sure I'm correct. So OpenTelemetry has two major parts. One is it's just a specification for how data is emitted and even transformed and collected. So it has like hundreds, maybe thousands of markdown files of like different aspects of observability being standardized, having specifications. So all the different tools are having the same format for logs, for example, right? That's one side of it, right? And then the other side is the thing called the collector, which is an implementation of the specification, the reference implementation. But it's how do we collect metrics, telemetry data? How do we process telemetry data? And then how do we send it somewhere, that telemetry data? Is that correct?
So slight correction on that. So we do have the specification, and there's like the SDK and the API. And so the API, I'm just going to like refer to my notes really quickly. So I am not blowing hot air out of nowhere.
Love it.
Let's see. Come on, notes. Here we go. Okay, yeah, so we've got the specification, and it's got the API and the SDK. So the API, it defines the methods for instrumenting your applications, and each language has its own API implementation. Now, but then there's the other part, which is the SDK, and the SDK is what determines how telemetry is generated and correlated. And again, there's an SDK for each language. And then, so that all that falls under the specification. And then we've got the collector, which is basically, you can think of it as like a data pipeline. So the collector is used to extract, transform, and load. A load being exporting. It ingests data from your code or from your infrastructure. It can transform your data. So the transformation can be things like, you need to do data masking, or you need to exclude certain data because it's, sensitive information, or maybe, maybe you'll want to sample your data because you're just like sending too much data out and you need to curb your ingestion costs. And then, or you need to batch your data because you don't want to be sending everything all at once, like this continuous stream of data. And then you've got the load part of your OTel collector, which is basically you're sending it. It's not so much load, but you're sending it somewhere, and that somewhere is like your observability backend that either natively supports OpenTelemetry, or you have like a special exporter for your observability backend, which basically transforms the data from the OTLP format, which is your native OpenTelemetry. It stands for OpenTelemetry Protocol. That's the native OpenTelemetry format, and can convert it to whatever format your backend supports if it's not compatible with OTLP. So then it's almost like this democratization of telemetry data, because now all observability backends theoretically have the ability to receive all of the same data. So the differentiator is, how are you going to render the data in a way that's meaningful to whoever is sifting through the data?
I'm lagging a little bit on what you're saying.
Yeah, no problem. Let me know, like, if I need to repeat anything. I am happy to repeat.
So collectors really have to do with
Data
extract,
pipeline.
transform, data pipeline.
Yeah. Extract, transform, and so it's ingest, transform, and then export data.
Cool. And specifically telemetry data?
Yeah, telemetry data.
Cool. So our telemetry data is now united under the common framework of OpenTelemetry, which has the two big parts. It's standardized how data is expressed and how data is collected, with definitions, the API and the SDKs, APIs and SDKs plural. And then we have collectors, which are like data pipelines for ingesting, transforming, and exporting telemetry data. Yeah. And then anything you said after that, I missed.
Oh yeah, no problem.
Yes.
Yeah, so just to clarify a little bit on the part one, where you have definitions, APIs, SDKs, I put API SDKs in parentheses, because that's like basically it represents like the definitions. So it defines how you instrument, and it implements it defines and implements the specification, I guess, is a way of putting it. So the API defines, the SDK implements.
Oh, okay. Definition.
Yeah, that's probably a better way of putting it, actually.
Okay. So for where to go out of implementations. Wow, that's a longer word than I realized.
So implementation is the SDK and definition is the API.
Got it. Oh. Cool.
And it's supported in a bunch of languages, which is awesome.
And a bunch of languages here and really all the tools, possible observability tools. And 1.0 days, they were all using their own their own standardization, their own languages, their own way of formatting things. And now it's all been standardized, which which not only enables holistic.
Oh, I was going to say in 1.0, we were definitely moving towards OpenTelemetry, but you're absolutely right that in the before times, like everyone was doing their own thing. And there was like some attempt at standardization with Open Census and Open Tracing. And then OpenTelemetry like merged those two projects and say, let's be friends.
Let's hold hands and get in a circle and sing Kumbaya. So, where do you want to go from here? We can dig in more on OpenTelemetry if you want, or we can. So, in me, like looking at all the different CNCF tools that can do the things, it's like, oh, FluentBit does logs, Jaeger does tracing. We can look at Prometheus for metrics. So it's still, how does that picture of all the views relate to this idea of OpenTelemetry?
So I guess so. Maybe let's pull back a little bit, because I think there's a lot of the times I think we get like very hung up on like tooling and like the idea of like, oh, I'm using OpenTelemetry, therefore I have observability, or like I love doing the analogy to DevOps. I am DevOps because I have a CI/CD pipeline, which like so not true. So like OpenTelemetry definitely enables observability, but at the end of the day, if you're not willing to make that mental shift of like, okay, gone are the days of APM. If you're not able to understand also like OpenTelemetry is a tool, as I said, OpenTelemetry is a tool that enables observability, but it's still up to you to make sure that you're collecting enough data and collecting meaningful data, because if you don't have the right data, you are absolutely unable to ask those meaningful questions of your system and get those useful answers.
So, can we go into how to know what data to collect?
So I would say this one becomes a very it becomes one of those iterative processes, I would say, and I think it segues quite nicely into one of the comments about wanting to know how to include observability in the SDLC, because I think so. Really, like it starts with the developers instrumenting their code, and in the same way that when you're writing code, you're writing print statements, you're writing log messages. That's just that's something we do as developers, to especially when we're debugging, to try to understand like why this friggin' bug is doing, why something is happening. And so getting into that habit of instrumenting our code with OpenTelemetry, it's similar to like adding logs in your system. It's similar in the sense that it's not something that we're not used to doing. I think there's a bit more of a learning curve with OpenTelemetry. But once I think you get the hang of it, it's a lot less painful. But there are growing pains with that sort of thing. So, but it starts with the developers instrumenting their code, and I think if they get used to using instrumentation to even debug their own code, like traces, especially. I'm a big fan of traces, and I think observability like it is powered by traces. All of the signals are important, those correlations are important, but observability is really powered by traces. So if you get in the habit of adding traces to your code, and as a developer being able to debug your own code by looking at the signals emitted by your own code, that's a great start. On top of that, then when your code is handed off to your QAs, there are two magical things that happen. Well, first of all, your code is instrumented. So when the QAs are testing your code and there is a bug, they can use the telemetry emitted by your code to help troubleshoot, to understand why is this bug happening. And so they can go back to the developers and say, hey, you have a bug. Also, here's where it is. On top of that, or do you want me to?
Yeah, slow down.
For a sec.
Yeah.
Slow down.
So, how do you get started adding observability? That's such a good question. I'm writing out the board, which doesn't happen often, John Paul. So, thank you. So you were giving some steps to your.
So you start by instrumenting your code in much the same way that you would add logs to your code. Just add some traces. Add some traces, add some logs, add some metrics to your code. Make sure they're correlated.
And then specifically instrument your code using OTel.
Yes. Using OTel. Yeah, exactly. So you're first off getting into that habit, because if your code's not instrumented, then if there are production problems, your friend SRE cannot help you.
Okay, and what's step 2?
So step 2 is then your code is instrumented, and it goes to it goes to QAs, right, for your testing, right? And the QAs basically, they can use that instrumented code to basically, if they encounter a bug, they can say, oh, I can use the instrumented data to actually understand why that bug is happening, so I can report back to the developer and say, hey, this is why it's happening.
Cool.
But is
there any nuance that we should be aware of in terms of instrumenting your code?
I would say instrumenting your code includes like adding traces, making sure you add traces, because traces give you that end-to-end picture of what is happening in your system. So you absolutely need those traces in there. Making sure that you add your logs, or there's something in tracing also in OTel called span events, where a span represents like an individual operation, or even like just it can be like a function call, or it can be like a set of operations within a function or whatever. But anyway, there's this thing called a span event, which is basically a log embedded in your span. So either a span event or a log, making sure span events are therefore correlated to spans and traces. Logs, making sure that they're correlated to your traces. When you're emitting metrics, make sure that they're correlated to your traces, so you have that holistic view. So
those correlations are happening at the code instrumentation level.
Yeah, that's at the instrumentation level, making sure like I want to say, don't take my word fully on this, but I want to say generally from what I've seen, when you're creating logs with OTel, that they are correlated back to your traces. I think for metrics, you have to do that. You have to do that yourself using exemplars. And I know it's been implemented in some languages, but not others, like Java for sure, .NET experimentally, and question mark for the others. I'm not sure where it stands right now, but that's where it was at least earlier in the year. So that's one thing to keep note of. So do you have any other questions around step one?
Not around step one. John Paul there's OTel testing also.
Yeah, I'll get into that. I'll get into that as well, assuming that we're speaking about the same thing.
Okay. Add correlations here.
Yep.
Yeah. That's part of step one.
Exactly.
Okay. Okay, so step two, we have QA. They use telemetry data to know that bugs are happening, or why bugs are happening.
Why bugs are happening.
It's very helpful there. Yeah.
Yeah.
Excellent.
Yeah, because then they can come back to the developer and say, like, this is what's wrong. Wouldn't that be nice if we got that kind of feedback from our QAs? But also, there's the other side of it. What if they encounter a bug, they're trying to use the telemetry data to understand why it's happening, but they can't figure it out? That means your code's under-instrumented. So then they can tell your developers and say, hey, you're probably missing some instrumentation here, which is fine, right? It's an iterative process.
So they either can use telemetry data to know why bugs are happening, or there's not enough data and they need to ask for more instrumentation.
Yeah, exactly.
The word instrumentation is so long.
I know, right?
A-T-I-O-N. Okay, it's on there. Code Wishon says they're uninstrumented, under-instrumented, not enough coffee. I'm gonna write QAs. Cool. So the idea here is that it's iterative.
Yes, exactly. Yeah, you get those feedback loops, right?
Mm-hmm. Step two is iterative. Cool.
And then there's like another aspect of QA, which hopefully answers John Paul's question from earlier, which is, so your system's already emitting traces. Why not use those traces to create test cases, like to create assertions based on those traces? So now you have these integration tests that are leveraging your traces, and that's known as trace-based testing.
Trace-based testing.
And we can shorten that to TBT.
It does have trace-based has a nice ring to it. TBT, yeah.
And that's something that your QAs can do. And I know like there were some original entrants into the market. So Aspecto had a tool called Malabai back in 2022. I think they don't maintain it anymore. And then Helios had an imperative set of libraries that leverage like OTel traces for trace-based testing. But there is still one tool out there that's open source that does trace-based testing, which is TraceTest. And they do declarative style trace-based tests with everyone's favorite YAML. I like YAML. I know there's like a lot of YAML hate. I like YAML. And the cool thing about them is that trace-based testing, a la TraceTest, was just integrated into the OTel community demo last fall. So you can actually see trace-based testing in action. And if folks aren't familiar with the OTel community demo, it's basically, if you're familiar with the with the Hipster Shop app from Google, this is the OTel version. We sell telescopes. And it's, multi-microservices written in different languages. You can see how different microservices are instrumented with OTel for these various languages. And I think they hit up like most of the languages that are supported by OTel, if not all. And then they've done this integration. They've added like the integration testing using TraceTest. So to the community demo, and I can pull up.
So trace-based testing is using trace data to create integration tests.
Yeah, exactly. Yeah, it's creating like you're creating assertions using the data from your traces. And if you're wondering what kind of data from your traces, that is an excellent question. So your traces often have like attributes, so name value pairs. So your traces will check for things like, your HTTP status, for example, or there's like a value returned from whatever that it's expecting. It'll like it'll look into those attributes in your trace to see if it matches the expected value.
Cool. And so the QAs are the ones that add the trace-based testing based on stuff that
Yeah, exactly. And I'm gonna share with you here the link to the OTel demo on on OpenTelemetry GitHub so that you can share it with folks who are watching.
All right. It takes me a little bit. Code with Sean has feelings about YAML.
See, I still prefer YAML over JSON. JSON looks like garble to me. I'm sorry, JSON lovers.
Yeah, YAML's more spread out. I like it too.
It's nicer to read. I know it's a pain in the butt when it comes to like getting dinged on the indentations where you're like, why? It's like I'm stuck on this problem for an hour because I missed 2 spaces. I still prefer YAML.
All right. Are there more steps, or did we do it? We added observability.
So that covers like, I guess, the QA part of it, and then we get our our SRE team, who is the recipient of all this lovely instrumentation. So they basically get the instrumented code, which means when things go sideways in prod, then they have the information at their fingertips so that they can ask those meaningful questions to get those useful answers. So that's part 1 of the SRE story.
Has telemetry data to ask the questions, but how is it correlated for them? It just already is correlated because
so the telemetry data is already correlated. So when they're like looking into the observability backend to like
Uh-huh.
understand what's going on, they have like all that information correlated so that they can use that to understand what's up.
System view. Okay. And you said that's one part.
Yeah, that's one part. But the other part too is like, so SREs have to create service level objectives because they help to inform them when the system starts behaving outside of the expected parameters, right? Now, service level objectives are based on service level indicators, i.e. SLIs, and SLIs are informed by metrics. So by having those metrics that our lovely developers have included as part of the instrumentation, so they have access to the metrics that they can then create the SLIs, which will eventually lead to the SLOs. Awesome. So then when an SLO is breached, they can go back to that SLO, trace it back to the original metric. Because our metric has been correlated to our trace, then we have a much more directed search into what's up, right? So you don't have this needle in a haystack sort of situation, because that's, I think, another difficulty that a lot of people experience with, you know, great, I have all this data, but where do I start looking?
So the service level indicator is usually okay. So investigate and solve problems, I think, is part of it. And then the other part is SLOs and SLAs. So this is like, basically, these are ways to define expected behavior.
Yeah.
Right.
So they use that information because the system's been instrumented with, among other things, metrics. They have the metrics to be able to define those SLOs for them. Well, they have the metrics that give us the SLIs, which then enable us to define the SLOs as a result.
I'm running out of room, so I'm thinking about how to be succinct with. So SRE team can now has to learn data and a holistic system view, and so they can use this data to can I just say define expected behavior to create SLIs and SLOs that define.
Yeah, exactly.
Behavior.
Exactly.
So I've heard before that one goal of observability is to know what goes wrong, like for you to be able to know what goes wrong in your system before your end users do. That means you're doing it right.
Yeah, that's true. Yeah, and I think that's aided by our observability backends, which can enable us to do that. Because I mean, OpenTelemetry alone can't do that. The observability backends will do, like, you know, the slicing and dicing of your data, and it's up to each one to sort of decide. Like, I think various observability backends will give you some inkling of like, oh, this is the expected behavior of the last week, but all of a sudden we've been seeing this weird blip. Perhaps you might want to look at it.
Cool.
We really filled that board, didn't we? This is like what causes me stress, because I'm like, I run out of space. I'm like, where do I put it?
Do you feel like we covered everything you wanted to cover?
There's one more thing that I did want to cover, which is like, you know, we've talked about how like the folks involved in our SDLC all participate to help make observability a thing and really fulfill the promise of observability via Observability 2.0. But there's one more thing, which is our actual pipelines, our actual CI/CD pipelines, which they themselves can be made observable.
Oh.
Dun, dun, dun.
Do you think that goes? It's part of adding the is the pipeline themselves part of the SDLC?
I would say it's part of the SDLC.
That's
I guess I don't love saying this because but I would say I guess the DevOps engineer typically in organizations, they're the ones who are in charge of like creating and maintaining pipelines. So I would say then they're responsible for they would be the ones that would make those pipelines observable, because there's like basically tooling in place that would that allows us, like you can certain tools like Jenkins, for example, they have an OTel plugin so that it'll emit like OTel signals. I want to say it's mostly traces, but it'll emit signals. Let's just say signals. Keep it broad, so that you have like information about your pipeline. And there's also this tool called sorry.
Just in terms of like organizing the information on the board, do you think this is like a step 6, or do you think this is like a standalone piece of information?
Good question. I wouldn't say it's a step 6. I feel like it would be like happening at the same time as like your developers are like instrumenting your code. Yeah.
Okay. And so I'm going to write it. So when I run low on space, I zip up my shirt and then I have a little where I was standing.
Engage zipper mode.
Exactly. So will you help me understand? So now with Observability 2.0, we can add observability to our CI/CD pipeline.
Yeah, exactly.
And what's the persona?
I guess your DevOps engineer.
Who does that?
It would be your DevOps engineer or your pipeline maintainer, whoever that is at your organization. But most likely, I would say it's the DevOps engineer.
Okay. And OTel really. We can add observability. I'm going to do the O11Y. 1Y, yeah, to our CI/CD pipeline. DevOps engineer.
Yep.
I'm just going to write DevOps. Cool. And then what does that look like in practice?
So in practice, it means that your pipeline, so first of all, you need tools, you need tooling that supports OpenTelemetry to do that. So as I mentioned, Jenkins does have an OTel plugin to emit OTel signals from your pipeline. There's also, I think Tecton also has an OTel plugin. So if you do build CI/CD pipelines a la Tecton, there is also this tool called the OpenTelemetry CLI, which I discovered was created by Amy Toby, and it's basically like, think of like your bash scripts instrumented with OTel. So basically, anytime you have like you're using like bash scripts in your CI/CD pipeline, you can include OTel CLI, and it'll emit OTel signals. I believe from talking to Amy, it emits traces only.
Cool.
And then Ansible has like I want to say a community plugin for OTel as well. So if you use Ansible to orchestrate like your deployments, you can get some OTel data there. And then Maven also has like a plugin. So if you're a Java person and you're doing Maven builds, you can get the hotels from your Maven builder.
Wow.
So the only kind of sad thing about this landscape is that there's no standardized tooling around it. I know there is like a group in CNCF Slack called hotel-CICD. I'll just pop that in the chat here. And they talk about these things because they want to like really standardize on hotel for CICD. It might be like, I haven't checked things for a while, but I know they've like really been pushing on getting that hotel standardization more broadly for CI/CD pipelines. Because I know at least the last time I touched this topic, and I gave a talk on it in November last year for Observability Day in Chicago. And at the time, like if you wanted to get any CI/CD observability for your GitHub actions, for example, like there wasn't anything available through GitHub itself. You had to use like a third party like GitHub action or plugin or whatever to make that happen. I know that there was like in GitLab as well, there was like some work around getting some OTel integration for their pipelines. I think
Cool.
but I don't know, like, I don't know where that's at right now, but you know, like it's not that there's a lack of interest, and at least there are ways to still have observability of your CI/CD pipelines if you so wish. It's just, unfortunately, there isn't like a whole lot of standardized tooling out there. It's a bit of a, you know, mishmash of stuff. So
it's an area where you can help be on the cutting edge. You, the viewer. Yeah.
Exactly.
So
It's
this
a very exciting
OTel
area.
CICD is a channel in the Slack CNCF, the CNCF Slack workspace.
Yeah, that's correct.
So you can get the latest information there, or if you want to contribute, you can do that there. If you have opinions, like maybe Robbie does, who says that would work well, OTel for CICD. Now you know where to go. Thanks for coming, Robbie. So the way we're going to close this out is I'm going to repeat everything you taught to me today back to you to make sure we have built a clear understanding. Before I do that, one last call for questions to everyone in chat. So don't be shy if you want to ask questions of our experts. And is there anything else you feel like you want to put onto the board before I do the recap? That question's for you, Adriana.
Oh, that question's for me. I think we covered all the things that I wanted to cover.
Okay, good.
Yeah.
Cool. So I'm going to go for it then. So first we talked generally about what is observability, and you gave Hazel Weekly's definition, which is like observability is being able to ask meaningful questions of your system and receive useful answers. That's the goal. So Observability 1.0 evolved from application performance monitoring, which you referred to as APM. So you're collecting logs, metrics, and traces, but not yet knowing how they relate to one another. So back then, there was a lot of focus on code operation, a lot of focus on known unknowns, and it's the job of the individual tools to do the correlation. So we kind of talked about those days being like Super Mario Brothers, like it was like platform games, like you know the boundaries of your system were a lot more clear. And now we have procedurally generated worlds as our systems. We're trying to watch Minecraft, so those ways of working no longer work now. So now we have Observability 2.0. So we're still talking about logs, metrics, and traces, which you referred to sometimes as signals. People also call them the three pillars, but you don't like the three pillars because it implies that they're all separate from each other. They're more like the three parts of a braid.
Yeah, exactly. That's a perfect way to describe it. The three braid parts.
The three pieces of hair don't quite have the right braid to it, though.
You heard it here first, folks.
But they work together to give a holistic view of the system. So they're purposeful events, and then they're correlated to each other. So it's not just about operating anymore. It's the way you're collecting your telemetry data is baked into the entire system, and using the telemetry data, not just collecting, is based into the system, the SDLC, which is software or system development lifecycle. So the thing that makes this all work is that telemetry data is now united under a common framework, and that framework is OpenTelemetry, which is also referred to as OTEL. There's so many acronyms today. So OpenTelemetry has two big parts. One is standardizing how data is expressed and collected. So we have definitions of APIs, and then we also have implementations, SDKs, that are part of the OpenTelemetry project. And then the OpenTelemetry project also has collectors, and those are like little data pipelines that you make, and you could chain different collectors together. But a collector is used to ingest, transform, and export telemetry data. So now we have OTEL in the mix. We have a more holistic view of the system. That's amazing. How do you do it? Like, what does that look like in practice? So OTEL or OpenTelemetry is a tool that enables observability, but you still have to collect the right data, and you still have to know what to do with that data once you've collected it. So what that might look like in practice is, for step one, you would instrument your code using the OpenTelemetry specifications. So you'd be collecting logs, metrics, and traces, especially traces, you said. And you're also adding the correlations at this collection level, at this code instrumentation level. And then once that's done, QA should be able to use the telemetry data to know why bugs are happening. And so if they do that, they could tell devs can fix the bugs. But the other thing that might happen at step two is that QAs might need more data to know why the bugs are happening. And at that point, then they're going to go back to the devs and ask the devs for extra implementation. So this process is iterative to get the loop right here. And then once we have that, then step three might be to add trace-based testing, maybe with a tool like TraceTest. And trace-based testing is using trace data to create assertions and using those assertions in integration tests. So then we have so that zooms out a level. So we have ideas of how different things are working with one another. And then we zoom out again, and we have the SRE team thinking about the entire system. So now they have a holistic view of the whole system, and they can investigate and solve problems. But more than that, they can use step 5, they can use this data, this telemetry data, to create SLIs, which are service level indicators, and SLOs, which are service level objectives. And they can define the expected behavior of their system. And once they do that, then they can know what the problems are in the system before the end users do, which is a huge deal. And then the cherry on top is talking about the frontier right now of this, which is being able to add observability to the CI/CD pipeline. So with OpenTelemetry, there's not a lot of standardization around it yet, but you can add OpenTelemetry to your pipeline. Tecton and Jenkins each have OTEL plugins, and Ansible and Maven do too. And I think that's a wrap. That's everything. We did get a question. Where does observability-driven development fit into this? Is that kind of what we're doing here? Or
yeah, that's exactly it. So, observability-driven development is the idea that you're instrumenting as you're coding, so that it doesn't become an afterthought. Now, that's easy for like new code that you're writing, and that absolutely should be a thing that you should be doing, because nothing's worse than like writing your code and then having to instrument it after the fact. Because you forget what's important, right? As you're doing it, and especially if you're using your own telemetry to debug your own code, then it's like so much better, so much fresher in your mind. Like you understand what you need versus what you don't need.
Absolutely. Cool. Oh, Chris Plank's here. Hello, Chris Plank. Says, great discussion today. Thank you for being here, friends. Still on all of my whiteboard. I call it a light board. And Code with Sean says, something I tell clients after they have metrics set up. Understand your nominal to better understand if and when something is in trouble. If a site is 20% slower, would you even know it's 20% slower? So that's great. So does that has to do with your service level indicators then and service level objectives?
I would say your service level objectives for sure. And also pointing out that like service level objectives, and I learned this from talking to Alex Hidalgo, who wrote the book on SLOs, literally. Great book, by the way. He said, when you first create your SLOs, they probably won't be great. And it's going to be one of those things that you're going to be iterating on over and over and over. Like your SLOs are never complete. And also as you make changes to your system, you might need to tweak your SLOs, or maybe your old SLOs go out the window, new SLOs come in. So
that's a life lesson too. Like just in general, like, yeah, everything's iterative. Nothing's really finished. So that's the joy of it. Yeah. Well, I think that's a wrap. This has been a really, really fun episode. Fuel Snowballs got here just in time for the dancing at the end. It's your favorite part anyway. And we have, Code with Sean agrees, as everything evolves, definitely iterates. And Chris Plank said something that I don't understand. Sedalia SLO? Do you understand that? Oops, no, trying to search for that book, author's name. Okay.
Oh, here, let me pull it up.
Okay.
One sec.
While you pull it up, I'm going to start the music again. Thank you again, everyone, for being amazing. Thank you, Adriana, for being a really good guest.
Oh, thanks for having me and for letting me yap about observability.
Oh, it's such a joy.
And I gotta say also, like, we're here because of the folks who have been like doing work on observability and talking about it and thinking about it. So, it's awesome that we got like those. As I said, like full credit to Charity for talking about Observability 2.0 and really switching the narrative in that direction and giving us that original definition of observability.
Sorry, I didn't mean to overdo it.
Oh, no, that's okay.
Okay. Do you have anything else you want to say over the music, especially before the bass?
Oh, yeah, and I also want to say, like folks like Amy Toby, who did the Hotel CLI, I think that's like really great. Just having that community involvement.
We're standing on the shoulders of giants.
We are. And of course, Hazel Weekly for her updated definition of observability, which I think is a very thoughtful one.
Awesome.
And for ladies in tech pushing the needle, right?
Yeah. I love it. Okay, bye. Have a wonderful rest of your day.